All right, well, welcome to NYNJPA weather video. Trying a new thing here, also including a webcam. It's pretty cool. So you get to see me, which I heard helps explain things. So we're going to give it a shot, right? This is a major storm. And I'm going to show you exactly what we're going to be dealing with this storm and why it's a dangerous storm. And I'm also going to go over some of the 12Z model guidance that just came out, okay? Especially the European guidance. Each model is showing a very interesting interaction between the upper level low and what's left of the warm core low of Tropical Storm Hermine. And the interaction's incredibly complicated. And this is why you see three different solutions. And three of them are all viable. So which one's right? Which way do you prepare? Well, look. If you're on the coast, be prepared. If you're in Trenton, New Jersey, if you're in Scranton, Pennsylvania, this will not be that big of a deal for you. Deal with some rain, some strong winds, but you'll be okay. But if you're along the coast, hey, you want to have a party with a storm surge coming into your home, good luck. So let's dive into this forecast. And currently what we have set up, notice the winds are already increasing anywhere from about 10 to 20 miles per hour along the coast, 5 to 15 miles per hour from the northeast. Temperatures are very comfortable, from let's say the lower to mid 70s. So overall not bad, right? When we take a look at the observations, and this will all be about Hermine, what I want to show you first is down here. This is 925 millibars, and let's see if I can turn this off. Here we go. Okay, so at 925 millibars, this is a warm core low. You have the warmest temperatures at the center of the circulation. Your stronger winds are generally focused around the low-level center, but we also see strong winds away from the center. At 850 millibars, generally see the same thing, okay? Where it changes in structure is at 700 millibars, where we start to see more of a, I guess call it a extratropical circulation, okay, an extratropical structure. And this is really important because what we're seeing here is a divide in the structure of the storm. And the tropical nature of the storm is at the lowest levels, and it's a bit ragged, obviously moving over land. So with that being the case, at 500 millibars, 500 millibars, we have no closed upper level low first. Important. And with that being the case, take a look at the thermal gradient here. Anywhere from minus 11 degrees Celsius to 1 degree Celsius, minus 1 degree Celsius. And this is important because this sets up where our upper level low is going to form. And this factor of the entire storm is going to be what's going to dictate how far off the coast the storm gets, when it starts to intensify, and how close does it get to the coast. So all these factors are coming together, and they're all working together. It's very interesting to watch how this is all setting up. Now, the radar. This is important now. If you're expecting steady rain from now all the way on through Wednesday, you missed the point of the forecast. As far as rainfall is concerned, if you're right along the coast, you're going to be dealing with a few showers today and for tomorrow. It's not really about the rainfall. It's about the coastal flooding and winds. If you're away from the coast, this is just scattered tropical showers, and you know what tropical showers can do. They can, in some locations, they can produce an inch of rain like that. In other locations, almost nothing, scattered clouds. What's the big deal, right? So that's what you're going to be dealing with out here. But as you get closer and closer to the coast, we're right on the edge here, so we're going to be dealing with some of these tropical showers and heavy downpours at times. So the radar really shows this really nicely, where you can see the evolution of the storm starting to take place. Notice how these showers are all starting to redevelop out here. That back building started to take shape as our warm core low is now pushing into the very warm waters of the coastal waters of North Carolina. So you see some of the factors here starting to take shape. This is clearly a cold core extratropical characteristic right here with all the heavy rain and convection well far away from the center. But we're starting to see redevelopment here starting to take shape. On the infrared satellite picture, very impressive. You can see the high pressure system strongly in control over the Great Lakes and over the interior New England. It's beautiful out, right? Take a look at this. Notice the convection really starting to fire out here away from the center. This is an extratropical characteristic of a storm. So clearly we're dealing with a post-tropical system right now. Key is right now. Okay, so we have that structure in place. But notice we still also have the low-level structure kind of showing up. And it shows up even better on the visible satellite picture. This is beautiful. This is absolutely beautiful. You have the low-level center off the coast. Now what we're going to be watching for is to see whether convection starts to develop. Those thunderstorms start to develop off of the coast, right around here. And that is when we're going to see real intensification of the storm. As the storm moves over the Gulf Stream and moves over this very warm water, and that lower structure, that lower warmer structure, starts to interact with all that warm water. And by the way, that interaction and release of latent heat energy also enhances the 500 millibar development because you're creating a stronger thermal gradient. Remember, extratropical is all about the thermal gradient, the vertical and horizontal thermal gradient. Tropical is all about the practice of latent heat release and that energy release and the release of more water vapor into the atmosphere and that process of cooling. That's what warm core is all about. So we're certainly seeing all those factors come into play here. So when we continue that, take a look at the water vapor satellite picture. And let me take this off so you can see very clearly what we're dealing with here. The water vapor is showing that interaction and the 500 millibar dynamic starting to catch up to this storm. And with that starting to evolve, we should start to see this storm start to slow down as it's moving east-northeast. Now, key thing to understand here is that the question in the forecast is when does that happen and how fast does it happen? How fast does that 500 millibar development happens where it captures this storm and pulls it back west? As far as the question of whether or not this will block, well, we have the blocks in place. You have your negative NAO pattern. You have your ridge over the western Atlantic, see that very clearly. And you also have your block in the Tennessee and Mississippi River valleys. So this storm is not going anywhere. It's going to be basically developing off of the mid-Atlantic coastal waters. So let's dive into these models and what it really says, okay? And this is really important here to kind of break this down. We're going to start with the Canadian. And the point here I want to show you is it's not about which model you like. Meteorology is not about following a Model A, Model B, or Model C. Meteorology is about taking the data you have, understand what the model guidance is doing, and then going from there. Okay, so if you understand what the model is doing and you compare that to the actual observations, then you come to a forecast. That's what a forecast is taking, okay, this crystal ball says this one says that. You look at the observations of what's going on now, and you use your brain, and you come up with a forecast. So now we got that down, let's really dive into the guidance here. So on the Canadian model guidance, we'll start on that first, okay? Let's see what it does. It takes the storm out, just like it's expected to. Then it rapidly pulls it back in towards the coast. We'll see if we can get this to play here. So it rapidly pulls it in towards the coast and takes it into the coast. Wow. So that's the Canadian model guidance. And if this actually comes to pass, then what this would basically lead to is just a completely impressive event setting up for the central and southern New Jersey coast. This would lead to major coastal flooding. Forget about the rainfall. The rainfall would be insane, but this would lead to major coastal flooding. Why is it doing this? Well, at 500 millibars, what it does is that it forms that upper level low by tomorrow morning and pulls the storm right into the coastal plain. So that's what the Canadians doing. What the GFS is doing is that it's allowing the storm to exit just a little bit further out and then stalls and weakens the storm off of the Delmarva Peninsula and over New Jersey coastal waters. It just kind of meanders around there and sends showers into the coast, but notice it steadily weakens throughout the period. Why does it do that? Well, at 500 millibars, it develops the upper level low by Sunday morning, but the upper level low rapidly sits right over the storm. What this is called is vertical stacking. And when that happens, you basically peak the storm out and then you rapidly weaken it. So that's solution number 2 until it heads out of the ocean. And finally, the European guidance, as some people call King Euro, okay, it takes it way out there and then pulls it right back in. And then it also stalls the storm until it heads out on Wednesday. So why does it do that? 500 millibars, forms the upper level low late, pulls it back in, but then becomes automatically vertically stacked. So the key in the forecast going forward is, where does the upper level low set up? Does it set up just to the west of the old warm core low? And if it does that, it pulls it right towards the coast. If it becomes vertically stacked very fast, it leads the storm to rapidly peak over the ocean waters and then start to weaken. So we're going to watch how this is all going to evolve. Each one of these solutions is viable, but I wouldn't change my forecast if I were you. So again, we get the idea of the tight gradient involved here with the precipitation potential here, where you got almost 2 feet of rain off of the coast here. And you got very heavy rain right along the coast. Again, pretty much staying 2 inches plus right along the New Jersey coast. And then as you move further inland, almost nothing as you head towards southeastern Pennsylvania. So to break this down for you real fast, again, what we're going to be dealing with here is today the storm develops off the coast, winds steadily increase, beach erosion, a few showers, but not all that bad as far as showers are concerned. Tonight, Hermine starts to rapidly intensify off the coast, off the Delaware coast. Most of the rain stays off the coast. A few showers are capable of tropical downpours. Winds steadily increase, and coastal flooding will become a major issue with the first high tide. Beach erosion becomes worse. Tomorrow, threats for showers increase along the coast, widely scattered the further west you go. Okay, to practically nothing out over eastern Pennsylvania. Winds become stronger from the northeast and noticeable even over the interior. Coastal flooding increases, beach erosion continues. Too late to leave the beach at this point, okay? Tomorrow night, heavy rain along the coast. Some locations, especially along New Jersey coast, will be a threat for rainfall rates of 1 to 3 inches per hour. This is the idea of a mix of all 3 of these model guidance, okay? Showers are further inland. Winds powerful, near hurricane strength along the coast. Tropical storm force winds just inland. So basically a very windy night tomorrow night. And then Monday, again, Hermine's pretty much sitting off the coast here. Waves of heavy rainfall working in from the coast. Showers widespread near the coast. Widely scattered as you move towards the interior. Strong winds throughout the region. Naturally strongest along the coast. Coastal flooding over hurricane strength is possible. It should say gusts over hurricanes is possible. Coastal flooding at major stages. Beach erosion continues. So we're going to be dealing with wind damage, flooding damage, coastal flooding damage. It's not going to be pretty along the coast. Okay. And then on Tuesday, Hermine continues to sit off the New Jersey coast with continued impacts, but weakening as it's doing so. And Wednesday, the storm leaves and we start to clear out. So, again, along the New Jersey coast, this is where I think where the worst impacts will be. Heavy rain, 2 inches plus from this storm by the time we're all said and done. 50 to 80 mile per hour winds are possible. Coastal flooding, major beach erosion. As you move a little bit further inland, 1 to 3 inches of rain possible. Look for tropical storm force winds with higher gusts possible. Long Island, as you head out towards Long Island, look again for the potential for 1 to 3 inches of rain, tropical storm force winds, 40 to 70 miles per hour, major coastal flooding, and beach erosion. As you move north and west of the major cities and over the Philadelphia metro, up to a half an inch of rain, an inch and a half of rain is possible with this storm. It's going to be a bit hit and miss depending on how far these bands get into the interior. Tropical storm force winds will be possible at times. And then as you move well north and west of Philadelphia, move into the Poconos, northwest New Jersey, Connecticut, especially central and northern Connecticut up towards Hartford, not much of an impact. A few tropical showers are possible, a quarter to maybe an inch of rain and some heavier downpours, winds 15 to 35 miles per hour. So that is the latest of what we're dealing with Hermine. We'll see exactly how this evolves over the next several days. This is a long duration event, and hopefully, fingers crossed, maybe this storm just decides to head out, but it doesn't look like that's going to be the case. So you can trust on NY and JPA weather, keeping you informed. Have a good day, and as always, stay safe out there.